everyone. I'm Priyanka and today we are going to start motion, which is the physics chapter from class 9 science. Now, physics is a conceptual subject, so we need to imagine each concept happening in real life, and that is when we can apply the concepts to the questions. So as we move throughout this chapter, I would personally suggest each one of you to relate each concept to what you have observed in real life. So let us move on. Now, motion is described as the change of an object's position over a period of time. Now, to describe the position of an object, we need a reference point or an origin. For example, a passenger inside a moving bus sees his fellow passengers inside the same bus at rest, whereas an observer from outside the bus sees all the passengers inside the bus in motion. For example, let us look at this image. Here we have Cosma's house as the reference point. The shop is 300 meters to the right of Cosma's house. That's why it's in positive value. And the school is 300 meters left from Cosma's house, which is why it's a negative value. So here we take Cosma's house as the reference point and we describe the position of the shop and the school from the viewpoint of Cosma's house. But now if we take the shop to be the reference point, we can say that Cosma's house is 300 meters left from the shop. That means it's minus 300, and the school is 600 meters towards the left of the shop. So depending on the reference point, the position of the object changes. The way we describe the position changes. Now, why do we need to describe the position of an object? Now, we need to describe the position of an object so that we know the final position and the initial position, which is the starting position and the ending position. So, only when we know the final point and the ending point can we calculate the difference between them, and the difference between them is motion. For example, in a basket you have 10 chocolates and now when you look at it there are only 8 chocolates. That means there are 2 chocolates missing. Now you wouldn't be able to count the 2 chocolates if you didn't know that there were 10 chocolates then and now there are only 8 chocolates. Now, the simplest type of motion is motion along a straight line. That is, as the word mentions, a body moving along a straight line. For example, a body at position C moves to position B and then from position B moves to position A, totally covering a distance of AC. A straight line means there is no positive or negative elevation. So, it is just a straight plain road in which you're moving. Now, before we move on to understand the various factors of motion, we need to understand two different kinds of quantities, scalar quantities and vector quantities. Now, scalar quantities are physical quantities which we can associate only with its value or magnitude, whereas vector quantities are physical quantities which we can associate with both magnitude or its value and with its direction. The first question that would arise is, what are physical quantities? Well, physical quantity is a quantity that we can measure, for example, length, time, and mass. Now, to understand the concept of scalar and vector quantities, let us take the example of a car. A car moves 10 kilometers and finishes its ride. This is a scalar quantity because we don't know in which direction it went. You don't know how it traveled, you only know how much distance it has covered. So that is a scalar quantity as you only know the value of the car's distance covered. Whereas a vector quantity could be the car traveled from position A to position B and covered a total of 10 kilometers. The value here is 10 kilometers and the direction is from A to B. Now let us see what distance and displacement are. Distance is the total path length covered while traveling, whereas displacement is the distance between the initial and the first position. Distance is a scalar quantity, whereas displacement is a vector quantity. Distance cannot be zero, which we will elaborate in the next slide, whereas displacement can be zero if the object comes back to the initial position. Let us understand this with an example. In this figure, you can see a boy has traveled from point A to point B to point C to point D and to back to point A. Now the total distance traveled would be AB, that is 3, plus BC, that is 5, plus CD, plus that is 3, and plus AD, which is 5, that is totally 16 meters. But the displacement would be 0 because he has traveled from position A and he has come back to position A. So the change between position A and position A is 0 because it is the same point. So the displacement is 0. Again, you can see that this is a vector quantity because the direction matters. He traveled in a particular direction and he came back to the initial position that he started from. Therefore, it is a vector quantity. Whereas in distance, the direction actually never matters. He went in 3 different directions, but at the end of the day, he covered 16 meters. That is the total path length he covered while he traveled. Now let us see what are the differences between distance and displacement. In distance, if a motion has occurred, distance cannot be 0, whereas displacement can be 0. Now here is a very important clause, that if motion has occurred. Why are we stressing on this point a lot? Only if motion has occurred, there is a change in an object's position. We already discussed the definition of motion, which is the change of an object's position over a period of time. So if there is no change in the object's position, there is no distance covered. So if an object has moved, that means it has covered a particular distance, so it cannot be 0. Even if the value of the distance is very negligible, for example 0.001, that much of a measurement has already been covered by the body, and that is the distance. But displacement can be 0. As we already explained in the previous example, the car started from point A and returned back to point A, where the displacement is 0, but this distance is not 0. Now, distance and displacement can be equal only when the body is moving in a straight line. We saw a car moving from point C to point A through point B. Now the distance covered would be 60 minus 25, and the displacement would also be 60 minus 25. You may rewind the video to just check the image once again. So when the body is traveling in a straight line, there is not much difference because it is moving in a straight line without any deviations. So the direction is always equal to displacement when the body is moving in a straight line. Now distance can never be negative because you can't move in a negative pace. But displacement can be negative because it is with respect to the position. For example, if you started from point A and then you moved all around, you reached point A and then you moved behind from point A, that means the total displacement you have covered is in negative value, whereas according to the distance, the total distance you would have covered would be A to A plus the backward distance that you covered. Now, uniform and non-uniform motion. We have looked at this topic since we were in grade 7, but this is just a normal reminder for all of you. Uniform motion occurs when an object covers equal distances in equal intervals of time, whereas in a non-uniform motion, objects cover unequal distances in equal intervals of time. Also note that the time intervals can be as small as it can be, but it would not change the result. Let us look at this graph here. We can see the car moves in hours from 0 to 4. It covers 10 meters per hour, whereas here the car moved 20 meters in the first hour and then 10 meters in the next hour and then another 10 meters in the next hour. So that is non-uniform motion because the object has moved in unequal distances from the start of the motion, whereas in uniform motion, the car has moved in equal distances in equal intervals of time from the start of the motion. As always, really appreciate you for watching this video. This was part 1 of the chapter Motion. For the subsequent parts of this chapter, please click on the links given in the description box. Please like this video, comment if you have any doubts, subscribe to our channel and share the video to anyone else you think would find this helpful. Happy learning!